Welcome to SS Mathematics classes for juniors. In our last lecture, in lecture number 4, I discussed about some basic types under method of substitutions to some basic types of integrals. There were 6-7 types I discussed in lecture 4, I think. Today, I will show you some problems on that types. Okay, let's see. First, I take this problem. Oh, before that, I am writing some standard integrals under method of substitution 2, which will be helpful to solve all these problems. See, number 1. Integration dx by x square plus s square equals to 1 by a tan inverse of x by a plus c. Number 2, integration dx by x square minus s square equals to 1 by 2a log mod x minus a by x plus a. Every time c is indefinite constant, actually constant of integration. Number 3, integration dx by a square minus x square equals to 1 by 2a log mod a plus x by a minus x. Number 4, integration dx by root over of x square plus minus s square. It may be plus or minus, in both cases the result will be log mod x plus root over of x square plus minus s square plus c. If it is plus, then read it plus. If it is minus, then you should read it minus here. And lastly, number 5, integration dx by root over of a square minus x square equals to sine inverse of x by a plus c. Let's see how to develop these formulas. This is nothing but an integral. If you take x equals to a tan theta, you will definitely get this part. For this integral dx by x square minus s square, you have to use the formula x plus a into x minus a. Then you have to part this 1 by x plus a into x minus a in partial fractions, and then you can get this thing. Similarly, you have to take partial fractions of 1 by a square minus x square. First, write a square minus x square as a plus x into a minus x, and write partial fractions. Then you will get this. For this, some steps are there. For this, you have to take log mod of x plus root over of x square plus minus s square equals to z. Only then you will get this equals to this. And for this, it is very easy. If you take x equals to a sine theta, here theta is the new variable, x was the old variable. If you take x equals to a sine theta, you will surely get sine inverse x by a plus c. But for brevity, we do not show the proofs of all these formulas. Instead, I start solving some problems from the textbook, which is SNZ textbook. See. Mostly, I follow in this lecture problems from SNZ. Mostly, I follow SNZ in this lecture. Okay. So, our first problem is from very short answer type question, VSA type. It is in number 4. I do not mention the number here. I am just mentioning serial number 1, 2, 3, 4. Integration x into 1 minus x square divided by x to the power 4 plus 1 dx. You have to split it up first. Okay. See how to do that. X dx by x4 plus 1, first part, and minus x cube dx by x4 plus 1. I split it up into two integrals. For the first part, you can write first part here separately. For first part, which is integration x dx by x4 plus 1, let us take x square equals to u. Then you will get 2x dx equals to du, or x dx equals to du by 2. Just put it here, half du by u square plus 1, and use our first standard integral which I wrote before. 1 by a, here is 1 tan inverse of x by a in that formula. Here u, tan inverse of u. Okay, don't put c here. Just put the constant of integration at last, because we are encountering two integrals. So don't put constant of integration separately. When you will write the whole result of this integral, just write the constant of integration like c at last. So this is tan inverse u, half tan inverse of u means x square. Now the second part. Second part is, see, integration x cube dx by x4 plus 1. For this integral, if you take x4 plus 1 as suppose z, then you will get 4x cube dx equals to dz. Very easy. Or x cube dx equals to dz by 4. Okay. So just put these things here. This is 1 by 4 integration dz by z, which is very easy. 1 by 4 log mod z. Don't put c here, constant of integration. You have to put that constant at last. Log mod z means x4 plus 1. Okay. So just write this minus this, you will get the result of this integral. So I am removing this first part. I think you have noted it already. So the result will be, I am writing the result. What was the result in the first part? The result was half tan inverse of x square, I think. The result was half tan inverse of x square, and this is 1 by 4 log mod x4 plus 1. At the end, I just put constant of integration. Here, you have to note one thing. Why we put logarithm, why we put modular sign after logarithm each time? Because we know logarithm of any negative constant or any negative number is imaginary number. Okay, but in class 12 we are not dealing with calculus of imaginary numbers. Actually, we deal calculus of imaginary numbers in higher mathematics. So for that, we generally put modular sign, because under modular sign, if there is some variables and if that variables may take positive values as well as negative values, and if you get ultimately a negative number and the logarithm of that negative number will be imaginary number, for that reason we put modular sign here. But here you see x to the power 4 plus 1 is an even function. Whatever x may be, if x is positive, well, x to the power 4 plus 1 is positive. If x is negative also, x to the power 4 plus 1 is positive. So there is no need to put modular sign here. I just said here, just you may write bracket. Just you may write bracket, because x to the power 4 plus 1 is an even function, so there is no necessity of putting modular sign here. So this is the answer. Next we take this problem, integration dx by e to the power x plus e to the power minus x. Integration dx by e to the power x plus e to the power minus x. I am just remembering this part. Hope you all have noted it well in your copy. So I am removing this part. So see, suppose I am solving a problem. I am solving an integral by taking some substitutions. You may solve that very problem by taking another substitutions. It may happen. For this problem, now just write e to the power minus x. Okay, instead of that, you may multiply numerator and denominator by e to the power x. It will be e to the power 2x plus 1. So these things, okay, these things e to the power 2x, and in the numerator, sorry, it will be e to the power x. And if you suppose just put e to the power x equals to v, therefore e to the power x, taking differentials on both sides, equals to dv. See, e to the power x dx, this part is matched up with this part, and this is dv divided by v square plus 1. Just follow the first standard integral I wrote in the first session of lecture 5. And what was that? Is 1 by a tan inverse x by a. Here a is 1, so tan inverse v simply, okay, plus c. That means tan inverse of v means here e to the power x. Let's see. This is the problem number 2. Under VSA type, I am not wiping out this part. Okay. Next, I am taking this problem, integration x square plus sine square x divided by 1 plus x square into sec square x dx. So just part it into two integrals. See how to do that? See, the numerator is x square plus sine square x divided by 1 plus x square into sec square. There is another part, into sec square. Okay? See how to deal with this type of problems. First, we have to manipulate the numerator in this way. See, x square plus 1 minus 1 minus sin square x. 1 plus x square into sec square x. Hope you understood all these things. I did not do much. I just took 1 here and adjusted minus 1 here. And all other things remained same. See, x square here, x square here. See, plus sin square x here, minus 1 plus sin square x. So I did not do much. I just took plus 1 here and eliminated by minus 1 because there was no 1. You have to maintain the balance. You cannot introduce any new thing in a given problem in this type of integrals. Always, if you bring something new, you have to adjust that also. Here I adjust plus 1 by minus 1. Okay. So now I am parting this. See, this by this is 1 into sec square. So this will be sec square x dx, and this is cos square. 1 minus sin square cos square into sec square, which is 1. So this is this becomes 1. So this is dx by 1 plus x square. And we all know what is the integral integration of sec square x. It is very well known to you. Tan x, and this is according to first rule 1 by a tan inverse x by a. Here a is 1, so this will be tan inverse x. And at the end, just write C, indefinite integral constant or constant of integration or arbitrary constant, whatever you say. Next, we will take a very small problem. D of log x divided by x plus 1. First, I want to tell you one thing. Differentials. Differentials. What is differentials? Differential of some function, say fx, equals to, just remember these things. Differential of some function, say fx, is f dash x, derivative of that function into the differential of the variable involved in fx. Here x is involved in the function f, so that's why I put dx here. If there were u in the function a, we had to put du here. If there were some other variable z in the function a, we had to put dz here. So this is very simple thing. So what is d of log x? See, we generally see dx in every integral, dx. Here we see d of log x. So you have to simplify these things. D of log x is first differentiate log x, which is 1 by x, and dx. So this is dx by x. So just put these things here. Dx by x into x plus 1. Very easy. Very easy. So just now you have to introduce partial fractions. Here the fraction is 1 by x into x plus 1. We can write it as, see, 1 by x minus 1 by x plus 1. If you take difference, you will get definitely 1 in the numerator and x into x plus 1 as LCM in the denominator. So this difference will match this difference, this fraction, sorry. So just one part is dx by x, the other part is integration dx by x plus 1, This is log mod x. Now here you have to necessarily put modulus sign because x is not any even function. Minus of, in the case of second, you have to also put modulus plus c. And this part you may write, I am removing the first two lines, and this part will be just use simple formula of logarithm, log x by x plus 1. This is the answer. So, okay, just note it down in your copy. Next, I take this problem. Problem number 5. Integration dx by 2ax minus x square. Always keep in mind all the 5 standard integrals. In addition to that, all the standard integrals you have so far. First convert this fraction 1 by 2ax minus x square into that standard type. See how can I get that standard form? Just a square minus a square plus 2ax minus x equals integration dx by a square minus, if you take minus common, you will get x square minus 2ax plus a square. So this will be integration dx by a square minus x minus a whole square. So we get standard integral 3 type integral here. What was the integral? What was the third standard integral in our today's lecture? That was integration dx by a square minus x. See, there is some resemblance with this integral. Here you can get a resemblance with this integral. So, for easy integration, we take x minus a equals to z. Therefore, dx will be dz, and okay. So this will be after substitution dz by a square minus a square. Now, after this substitution, what we got is just matched up with the standard integral. See, just put the standard integral, which was 1 by 2a log mod a plus z by a minus z plus c equals to 1 by 2a. Always you have to bring back the original variable, otherwise marks will be deducted. So z, what is z? X minus a. Just put x minus a. You will get x in the numerator by a minus z. X minus a again, x plus c. Okay. That is 1 by 2a log mod x by 2a minus x plus. See, this is the result. This is the result. Next, first note it down well. Okay. Hope you all noted it well. Next, I take another problem which is from short answer type question in your well-known SNA book. Okay, short answer type question. One, I name it one, but actually the problem is in number 2. Integration dx by root over of 2x minus x square. This is the problem. You have to adjust this thing, the denominator, and more precisely the expression under this radical sign. You have to adjust this to get standard form, any standard form from 1 to 5. I discussed earlier. Just introduce 1 here, minus 1 plus 2x minus x square. Okay, I write 1 and adjusted it by minus 1. So this will be integration root over 1. If we take minus common, x minus 1 whole square. You may write, you may think 1 as 1 square. So this will be after suitable substitution, you will see this standard integral. I am writing integration dx by root over of x square minus x square. I think it is in serial number 5. Standard integral I wrote today. You will see this type of integral after suitable substitution, of course. Let us put x minus 1. Let us put x minus 1 equals to u. Then take differentials on both sides. Dx equals to du. Okay. So what happens then? Okay. What happens then? Dx equals to du divided by root over of 1 square minus u square. Okay, it is just in this form. See, so what was the result? The result was sine inverse of x upon a. This was the result. So just put sine inverse of u upon 1. That is sine inverse of, what is u? U is x minus 1. That's it. So this is the answer. Okay? Just note it. So every time we see, so far in today's class, every time in solving all these problems, we see we have to use the standard integrals. So far, the problems I discussed, all the time I used the standard integrals I mentioned under serial number 1, 2, 3, 4, 5. So let's see some other problems. Number 2, integration dx by x square plus 4x plus 8. How to tackle this integral? Always keep in mind, you have to bring your integral into some standard integrals you already knew. X square plus 4x plus 4 plus 4. I split 8 as 4 plus 4. And the first part is very easy, which is x plus 2 whole square. Integration dx by x plus 2 whole square plus 2 square. So after suitable substitution, if you take x plus 2 as z, you will get this standard integral integration dx by x square plus s square. Okay, so just take x plus 2 as z, therefore you will get dx equals to dz. So dx equals to dz, okay, equals to d. So dx, what is dx equals to dz divided by this part x plus 2 was z, that is z square plus 2 square. It is just in the standard form 1. Okay, it is 1 by a is to tan inverse of z by 2. Let's see. And don't forget about back substitution. Finally, you have to bring back the original variable x here. Here z is x plus 2 by 2 is the end of this integral. Okay, so I am removing this part. I am going a bit fast. You have to note well. First, because only then I can cover a good number of problems in a single lecture. So you have to write first. You have to copy first. Okay. So see, in the next problem, number 3, I think, under short answer type question, here it is under serial number 7, support 2 in a single book, but I am maintaining my own serial. Integration x dx divided by x4 minus x square plus 1. So every time keep in mind you have to shape the given integral into some standard integrals. Okay, so x dx divided by x4 plus 2 x4 minus 2x square, okay, plus 1 plus x plus instead of writing this way, write this. X square plus x square minus x square. Okay. Equals to x dx divided by okay, don't do all these things. Instead, first don't do all these things. Actually, just take first x square equals to z. Then you will get 2x dx equals to dz. Okay, so this is half dz x dx is dz by 2, that is half the outside, and z square minus z plus 1. Okay, so half this will be better. Then I wrote first things, z square minus 2 into z into half plus 1/4 plus 1 minus 1/4. I balanced 1/4 by minus 1/4. Okay, just put first brackets here. See, half integration dz by this part is nothing but z minus half whole square, and this part is 3/4. You may write root 3 by 2 whole square to to see the given problem in exact standard form. Okay, so now you have to put a substitution. What is that? Okay, sorry. Now put z minus r to get this in exactly standard form. Put z minus r equals to u. So see, in this problem I have to substitute twice. First, I substituted x square by z. Next, I am substituting z minus half by u. So this is the first problem where we have to substitute twice. So this will be half in the outside. Dz is du by u square plus root 3 by 2 whole square. Okay, so this is just exactly in this standard form, which is x square plus s square. And what was the result? The result was 1 upon a tan inverse x upon a. I am not writing constant part c. So this is exactly in this form. Okay. So what is a here? Root 3 by 2. 1 upon a means 2 by root 3. 2 by root 3 tan inverse of u upon root 3 by 2. Let's see. Okay. Hope you understand well. Okay. 1 by root 3 tan inverse of what is u? U is just z minus half. Z minus half by root 3 by 2 plus c. You can adjust numerator and denominator by multiplying 2z minus 1 by root 3 plus c. Okay. Okay, and this is you have to bring back anyway the original variable. And what was z? What was z? Z was x square. I took x square as z. Remember, so just put x square in place of z here. 2x square minus 1 by root 3. This is the end of this integral. Okay. Okay, this is the end of this integral. And this is the standard integral here I used. Hope you understood all these problems based on the standard integral, actually based on, if you see closely, whatever problem today I solved, all these problems fall in different types, in different category of integrals I discussed in our lecture 4. Okay, this is not end of this chapter, that is method of substitution 2. In our next lecture, I am coming with more problems on method of substitution too. And hope you enjoyed this video and subscribe my channel SS Mathematics Classes for Juniors. Okay, thank you.